Okay. Welcome everybody to the 2022 Spawner Survey Workshop Training. We're doing a virtual copy so folks can look back at this and use it as a reference, or for the few people who just can't make it to the morning session. And my name is Erin Matthews. I'm the coordinator for this program, and I'm the Habitat Restoration Coordinator for Skagit Fishery Enhancement Group. And every year I oversee this program with the help of an AmeriCorps member, and this year that is Mariah, so everybody will also be working with her, and Lucy is always in the background helping with outreach and education things as well. So Lucy DeGrace, education and outreach manager for Skagit Fisheries, is also on the team. Before we get into the bulk of things, I wanted to acknowledge that the lands that we're going to be surveying on, and the lands that our office is at, and a lot of the lands in the Skagit for people who live locally, they're all historical native land for the Coast Salish people, and they still are today. So we are grateful for the land that they stewarded for time immemorial and all the water that it touches. We're dedicated to working with the local tribes, which includes the Swinomish, Upper Skagit, Soxhawtl, and Samis, just in this local watershed, who call this land home. And we work together to develop restoration projects that respect their past and present, including their ancestors and future generations. And we have a shared vision of healthy salmon, healthy habitats, abundant food, close community, and we're working together with them to make that happen. So the morning presentation is going to include introductions, plans. I'll just touch really quick on what's going to be covered in the afternoon, so that if you have questions about those things, you know that it's coming and we're not going to skip anything. Then we're going to do a Spawner Survey Program and Skagit Fishery Enhancement Group quick overview, who we are, why we're here, what are we all participating in. We're going to go over salmon in our region, how to identify them and their ecology. Then we're going to do how to collect spawner survey data for this program. And there's a quiz at the end, so get ready for that. It's a group quiz though, so you'll have to unmute and pipe in. And then in the afternoon, not in this session, in person, there's going to be a break between the morning and afternoon sessions. There's going to be a carcass dissection where we actually get to look at the inside of a salmon and look at the anatomy, look for the reproductive parts. There's going to be a safety training given by our AmeriCorps Restoration Associate, Mariah. We'll do a red identification demonstration. We know that that's something that is particularly difficult for new volunteers, so we want to do some of that in person, looking at the gravel. And then we'll check out gear for folks who have let us know what sizes they need. We'll have them on hand. So who is Skagit Fisheries Enhancement Group, or SFEG, or SFEG? Those are all ways to call us. We are a regional fisheries enhancement group. There's 14 of us in the state of Washington. They were all created in the 90s to fill the gap between private citizens and government and tribal groups that were all interested in habitat restoration. And our niche is non-governmental, non-regulatory, nonprofit. And we do a lot of work with private landowners, but also on public lands as well. Our work area is highlighted in purple on this Washington state map. And the Skagit watershed doesn't strictly follow the Skagit County borders. The watershed goes up into Whatcom County, down in the Snohomish, and we also do work out on Island County. And then we've got our sister organizations, the Nooksack Salmon Enhancement Group to the north, and the Sound Salmon Solutions to the south, covering numbers 1 and 3. Altogether, we cover every salmon-bearing watershed in the state of Washington, and we all do restoration projects and science education to achieve our mission to have healthy, robust salmon for future generations. We're funded by grants, donations, contracts, and we heavily rely on volunteers who donate time. So it'll be super important to turn in your time cards, because we report the donated time that you folks are giving to us at this moment and are going to continue to give to us in most of your cases to the grants that fund this project, this program. So we'll track you down and ask you how much time you've been working with us if we haven't seen a time card. And these are some pictures of the other work we do. There's an in-water work project where everyone's wearing their PPE. That'll be important. Mariah will tell you what personal protective equipment we want you to wear while you're working outside. And on the other side over there, we've got some community members planting trees and doing some riparian restoration. So the spawner survey program is what everybody is participating in at this moment. It is a long-term monitoring project that covers about 24 creeks per year, although it started off a little smaller and has escalated positively to cover more and more creeks. It's in the Skagit and Samish basins. The information that is collected by staff, AmeriCorps, and volunteers is sent to the Washington Department of Fish and Wildlife, which is a state agency, into their long-term database. And it's also utilized by them to calculate future return forecasts, and future return forecasts go into things like setting recreational catch limits for fishing. So it's super important data. They do a lot of spawner surveys themselves, but they have trusted us for many years with some of their index reaches, which are their most important streams to collect data from. And the fact that this data is used by the state and partner organizations is why we pride ourselves on high quality data and not allowing data gaps more than seven to 10 days between surveys. And it's because this is real scientific data that's really used by other organizations. We also, depending on the reach, share with landowners, we share with other organizations, and we've even shared with regulatory organizations when there has been potential damage to a stream and somebody needed proof that there were salmon. And so we did have that proof because of this program. It also gives our staff information about the health of sites with past projects, and it helps identify future projects. So we like to know, if we do a project, do we see more salmon coming to that area? Does that mean our project was successful? It's hard to say with just a year or two of data or 1 or 2 salmon sightings. It's impossible to say if a project is successful. When we monitor sites for many years before and after, that gives us more information about if for example, a barrier removal project actually allows salmon to pass upstream. We take this information and we put it in grant applications when we're proposing money. They always want to hear how we know salmon are there, how much will this project we're proposing stand to help salmon. And they really like to see recent data. So this recent salmon presence, salmon spawning data, if we have it, we'll report it and we'll utilize it to get more and more work done. We have 22 years of data. The program began in 1998, telling us where there are salmon and if our projects have been effective. So just because you're taking this training doesn't mean that you have to sign up for a stream, but many of you will. So if you sign up for a stream, the volunteer commitment will go from mid-October. You can start your stream as soon as you have your stream assignments and safety paperwork in, but everyone has to start by mid-October. And then for most streams, it'll go until late December, although there are a few very fishy streams that our teams may have to go into January, and that is really dependent on the weather. The streams range from 2 to 8 hours, 1 day per week, and it just depends on if you've got a short local stream that's easy to walk or if it's a rough, steep stream. Each pair of volunteers will survey an assigned stretch of creek every week. You'll get 1 creek that's yours, and you'll check on, collect data from that creek about every week. Our goal is to start surveying about 2 weeks before the run starts, and then to survey another 2 weeks after the run ends. And that reassures us and our partners that we collected data on the entire run. So if you know salmon are not at your reach yet, that's good. That means that it is the right time to start. You don't want to wait to start your reach until you don't see any more fish, or end your reach and surveying your reach any sooner than 2 weeks after the last fish was observed. If you can't make that 7 to 10 day data gap, then let us know with as much notice as you possibly can, and we can help find a substitute for either one of the pair volunteers or both. There are people who are interested in filling in and seeing other streams. So if you're interested in that, then let somebody know at the training during one of the breaks before stream assignments are given out, and we'll take that into it. We'll put you on a on-call list. And if you're invited to fill in, of course you can say no, but we just want to know who might be interested in that. You'll submit your data to SFEG weekly. And that's because we just want to know that you're getting out there and being successful. If we notice that it's been over 10 days since we've seen a data sheet from you, then we might reach out and check in. And please, at all times, follow all the safety guidelines and rules that you'll hear about today to keep yourself safe. So the next section of this training is going to be about salmon ecology and salmon ID. Does anybody have any questions so far? Okay. Didn't hear any questions. So we'll get into the salmon identification part of this presentation. So we're going to go over watershed specific information, but the things that we talk about today about ecology and run timing, know that that is very region specific, and that salmon and salmonids and trout have a really diverse life history. They all have different timing. They spawn in different parts of their rivers. These organisms are distributed all over from Canada to Alaska to the Arctic, and then in some cases over in Asia, in Russia and Korea and Japan. And there is a lot of diversity. So we are going to focus on our local neighborhood salmon, but if you're from another part of the West Coast, this might be different than what you know about those local populations, and that's okay. That's how salmon are. They're very dynamic, and they're very well suited to their local environment. Despite this diversity, they do manage to show up at the same place at the same time to find each other. So that's fascinating to me. We'll go over how to identify salmon, and part of that includes their biology as well as how they look. And then we'll discuss salmon and trends in this, again, local part of the world, not in all of Washington or all of Puget Sound, and definitely not on the West Coast of the world. So this is a little bit of a better map of the Skagit River watershed. Again, it does go all the way up into Canada and on into the neighboring counties. And so our reaches are all the way up from like the mid upper parts of the Skagit River up by Marble Mount and the national park over in this area to there's a few reaches in the Samish River, which is a little watershed that's between the Nooksack up here and the Skagit. It's a small basin, but it's got a lot of salmon. So most people know this, that's why I'm going to cover it really quickly, but if you have any questions, just ask anybody at a break. Salmon are anadromous, which means that they begin their life in freshwater, and then the Pacific salmon, most of them, mature in saltwater, and then when they're ready to reproduce, they migrate back to freshwater, and that's called anadromy. It's a super important part of this part of the world, because it's one of the only ways that nutrients, instead of washing downriver to the ocean, come up from the ocean to the forests. And this really dynamic, widespread life history needs a chain of healthy habitats. So if we want healthy salmon, we can't just have healthy streams. We can't just have a healthy river. We've got to have a healthy estuary, and we got to have a healthy ocean. So spawning behaviors that you'll see this time of year, the females dig a nest, which is called a redd, in an ideal location. We're going to talk a little bit about that in the data collection section, so worry not. The males compete for a spot right next to the female so that when she lays her eggs, he's in close proximity to her and he can fertilize them. When she's laying her eggs, the eggs have seconds to be fertilized before they harden, because they have to get hardened and ready to be buried under rocks, and they can be quite deep. If the female fish is large, she'll dig a large red, and they can be at least several inches, if not over a foot down in the gravel, because they want to be protected from flood scouring, for one, and then also from getting dug up by new fish making new reds. This is really damaging to the females, so you'll often see that their tails are torn up from this process. The Pacific salmon are simulparious, which means they only get one chance to reproduce in their life, and they really go for it. You'll see at the end of their life that they can be, they'll have white spots on them sometimes. That's fungus growing on them while they're alive. They stop eating quite a bit before they are digging their reds and reproducing. They do it all on their body fats that they have stored up. And then worry not, we're going to cover more reds in the future. We'll start with the 5 Pacific salmon, and then folks wanted to hear a little bit more about a few other species, so we'll add that to the end. But for this next section, we're going to be talking about the 5 Pacific salmon species: Chinook, coho, chum, sockeye, and pink. And some of this biology we talk about is going to be just about Pacific salmon only, not about trout. When you identify a fish, you're going to be looking at a myriad of factors, and then you'll consider all of those factors together to make an identification decision. These factors are going to include size of the organism, the shape and coloration of the body, and other specific features. And what you don't want to do is go off of color alone, especially color of just one feature. You're going to want to consider multiple features together, because these fish are so closely related that is not common, but they can hybridize with each other. So they do look similar. So we're gonna take a big picture view on identification here. And then we're also going to use habitat and ecology factors when making our ID. So we're gonna consider creek size, because different fish prefer different habitats. We're going to consider the time of year and the year. We'll get into why if it's an even or odd year that matters. So these species run at different times. So in a given month, you might not expect to see a certain species, and you might be very hesitant to make an ID. And here's the slide about that. So this very simply shows the approximate run times of the 5 Pacific salmon. So for example, in December, you see that you have coho and chum expected, and you wouldn't expect to see an adult Chinook spawning in late December. However, if it's October, it's one of your first surveys and you're in a large stream, you can see that the beginning of the coho run and the end of the Chinook run can overlap. Absolutely. So then you might be considering, if you start looking at a fish, coho, Chinook, or according to this chart, if you're only thinking about runtime, sockeye. But then you can start thinking about habitat preferences and eliminate sockeye. Tend to prefer the lake, streams associated with lakes, although there are river type sockeye. And Chinook tend to be in big tributaries and the river, and they also look different. So let's talk about Chinook salmon. Chinook are also called king, because they're one of the biggest. They are the biggest salmon, and they're one of the most prized for recreational fishing. They are listed as threatened under the ESA, the Puget Sound Chinook, which is what we have in Skagit. And there's some data from a few years ago that indicates that the Skagit River might be home to up to half of the remaining Puget Sound Chinook. So it's really a treasure that we are living in and working in. There are 6 unique stocks in the Skagit watershed of Chinook. They are genetically distinct from each other, and they have different behaviors from each other. So you might have heard about spring Chinook and fall Chinook. That's an example of some diversity that we see between these stocks. Luckily for us, if you're doing identification, then we're not going to be needing to tell the difference between stocks. This is just some local biology about Chinook. These stocks are really reliant on estuary. For the stocks that rely on estuary habitats for rearing are the most at risk. Estuary habitat has been really impacted by human activities in the last several decades. And there's some of these Chinook stocks spend time rearing, a long time rearing in the estuary, and those that life history strategy has a hard time with all of the habitat loss. This is a figure made by the Skagit Watershed Council. It does end in 2018, but it's the best one figure to show the local trends in salmon. There hasn't been a super significant change in any of these populations enough that these graphs aren't useful anymore. So in the last 4 years, there hasn't been any huge reversals of trends. So since the 1970s, Chinook escapement, so how many, so this includes summer and fall populations, and it's shown in green, and then spring populations in blue. So at the bottom, there's a lot fewer spring Chinook. It's pretty flat. So luckily they're not rapidly decreasing, but we'd like to see a trend line a lot better than this. That includes recovery, not just maintenance of the population. As I said, Chinook are the largest fish. Between 24 and 60 inches is average, although they can be much larger. They overall are a robust looking fish, and they have a large, one of the ways that it's easiest to see this robustness is a large peduncle. That is the part of the fish at the back of the body, right before the caudal fin. And this is going to be in contrast to another species that is quite large, but has a different shape. So this is a big, beefy, strong looking fish. They can be olive color, but also red. They tend to be more olive on lower latitudes, and then they tend to be more red at more northern latitudes. In our area, they're typically olive, but you can see some deep red on the sides of their body sometimes. They can be almost black or dark gray on their back. They will have spots on their back, dorsal fin, and on both lobes of the tail. Although if the tail is beat up by the time you observe them at the spawning grounds, you may not be able to use the tail for identification. And then another name for the Chinook or king salmon is blackmouth, because the lower gums next to the teeth can be black. In some populations, they are all black, and it's really striking, the color of their mouth. Where we work and live, you're going to be looking at the tissue right next to the teeth, and it can be pretty difficult, and we can't go off that alone. They prefer large streams in the main stem. They build big redds and move large, up to 10 centimeter in diameter rocks to build their redds. We're going to expect the fall Chinook to be running August to October. So we'll see the tail end possibly of their run. And the higher up in the watershed, the later you might expect to see them. So here's a picture of the mouths. The bottom left picture is the textbook, easy peasy, black mouth ideal situation, where you see that, you're looking at a Chinook. And this is contrasting with coho, who overall in body and color can look pretty similar to Chinook. And as we saw on the previous figure, their run times overlap. So they are sometimes in the same place at the same time. Coho are going to have they have black in their mouths, as you can see from this picture, but the tissue next to the teeth on the bottom of the jaw is not black in coho, and it is in Chinook. On the top left, you see, it's a little pixely, but you see a picture of a Chinook that's pretty difficult. It's not all black, but there is black tissue next to the teeth. And this is another reason why you look at the whole fish and not just one feature to do the ID. If you don't know if you're looking at a Chinook or a coho, an excellent photo of the bottom of the mouth is going to be a really important thing to collect, to send to me to help you make that final ID, in addition to pictures of the other features we've talked about. Same with coho. Mouth color is not going to be important for identification of the other species. But when in doubt, just take a picture. Chinook salmon, as I said, prefer large streams. They spawn in deeper water. They're big, powerful fish. This can include large tributaries and the main stem of the river. They typically don't get into the finger tributaries of the watershed because they don't really like breaching the surface. They don't like scooting up a section of creek that's only a few inches deep and puts their body out of the water. They make large redds, not only deep, but wide and long. We'll see a picture of that at another slide. And if you see any Chinook, you'll be seeing fall Chinook. Next, we're going to talk about coho. They're a mid-sized salmon, not the smallest, not the biggest of the 5 Pacific salmon species, averaging 7 to 38 inches, although the biggest individuals can be a little bigger than that. The males can have a very hooked kype. So they get this, they get changes in their beak structure when they go from an ocean fish to spawn in the freshwater. And if you see a really exaggerated kype, that is a feature that can make you start thinking coho, but other species get it, and not every individual coho will have this feature. There's also sometimes a misunderstanding that by looking at the how pronounced this kype is, you can tell if a fish is male or female. And I do encourage you to look at the fish and to make a guess if a fish is male or female, but then we are going to want you to, for the first 20 carcasses you find, to actually cut them open and check at their anatomy. And I had a lot of fun doing that with my spawner survey partner when I surveyed a stream for a whole year, and we found that we were not very accurate. Some females have very large kypes and some males don't. So there is an average, on average, males tend to have this feature. It's a more masculine feature, but it can't tell you everything. You got to open that fish. You also on this picture can see this structure near the kype, which looks like a nostril. It's not a nostril, they breathe with their gills, but this also can be very white. And even on alive individuals, sometimes from several feet away, you can see this feature. And that headlight white spot on their kype is a indication that you're looking at a coho. They tend to be green on their head and on their back, and then a deep red in their body. There is sockeye have green heads and red bodies, but it's a big difference in how gradually that green goes into the red. The sockeye are more like a cartoon with a green head and then abruptly a red body. And these fish are more of a maroon olive color. They tend to look more like Chinook. They have less spots on their body, on their dorsal fin and on their tail. They often have no spots whatsoever on their tail, but some individuals can have a few spots on just the upper lobe of the back caudal fin. So if you see a few spots because the tail is not damaged, that's okay. It's one of the reasons that you can confuse them with Chinook. Coho are going to be the majority of fish that we document in this program, and their runs go from October to January. That's what we're targeting when we pick our start and end dates. And I already covered a lot of this. You can see spots on their back, and as I said, the upper lobe. So that's going to just be one factor in your ID. And then, as we talked about, there are light gums, contrasting with Chinook. This is a graph from the mid-70s until 2018. Coho are not listed as an Endangered Species Act species, but the trend is not what we like to see in the Skagit River, and it's very variable year to year. Folks who've been with the program a few years know that 2 or 3 years ago, the returns were not good, and a lot of folks didn't get to see any salmon all year. It's still really important data, but that's not what we like to see. So we'd like to turn this around and see a better trend with our restoration work. Okay, next we're going to talk about the chum salmon. They're also called the dog salmon, and they're also called Keta salmon due to their scientific name, Oncorhynchus keta. I usually see Keta in grocery stores because chum and dog salmon don't sound as appetizing, I guess, as Keta salmon. These are large fish, smaller only than the Chinook salmon. They typically spend 3 to 5 years in the ocean before returning to their natal stream. When they come out of the gravel as newly hatched juveniles, they migrate out to the estuary pretty quickly and then rear in the estuary. When they're spawning, they are really attracted to and reliant on groundwater seeping from underneath the bed material in a stream out into the water channel. They have a strong sense of smell and they look for that water flow, and it's because it oxygenates their eggs and prevents their young from suffocating in the gravel. So when you're watching them spawn, you'll see them look for those habitats. In 2002, they were considered healthy in the Skagit, and then they were only considered stable in 2010, which is a little downgrade. However, in recent years, all over Puget Sound, there are runs of chum that are super low. So in the Skagit, our chum are not listed as under the Endangered Species Act, but in the Puget Sound, there are stocks that are. Here's the trend line for Skagit River chum. So if you go back and you look at this presentation, I encourage you to take a look at the y-axis. So we're just talking about trend lines, but there is a big difference in the number of returning salmon. So the number of chum that return is higher, for example, than Chinook, but the trend is not what we want to see. That's why chum in the Skagit are not listed as under the Endangered Species Act, and Chinook are is the number that return. These fish, as I said, are quite large, 35 to 45 inches long on average. They can be a little bit bigger. They have like a football shape. Remember, we talked about the robust, wide, sturdy looking caudal peduncle at the back of their body near the caudal fin. So these fish are also can be quite large, like a Chinook, but they have a more, and you get the hang of this when you've seen a lot of fish. They have a more dainty caudal peduncle. They're football shaped with a smaller back of their body and a different taper to their head. The spawning colors of these fish are really beautiful. They can have maybe a green, an olive, or a gray on a lot of their body with vertical calico bands that can be purple and red. And the males can have quite large teeth. You also see this change in their kype from their ocean form to their river form. It's just typically not as pronounced as other species such as coho. Those big teeth are helpful when males are fighting each other for that ideal spot right behind a female that they want to be in when they go to fertilize eggs. And they'll bite and chase each other. They can be quite aggressive, competing for their chance to reproduce. Oh, you'll also notice a lack of spots on the dorsal fin and the tail. So chum often spawn in small streams, lower in watersheds, although there are chum populations that'll travel over 2,000 kilometers to spawn, but in general, especially in the Skagit, they tend to be in the lower parts of the river, not the upper parts. And they run November to January. So this, besides coho, which is the most numerous species we typically see during our spawner survey program, chum are the second most in non-pink years. We'll talk about that. We'll talk about that right now. So 2022 is not a pink year. Pink salmon have a pretty strict 2-year life cycle. So we talked about ages of salmon in some of the other slides. Chum live 3 to 5 years, return after 3 to 5 years. Pink salmon return at 2 years old. They're pretty consistent in their size. And what this leads to is a pretty strict on year, off year, on year situation where, and this in the lower latitudes, and that includes us, the pink years tend to be odd. So 2019, 2021, and next year, 2023, and they're off in 2022. We do have a few once in a while salmon that stray from even years populations and show up in the Skagit, but they're extremely rare. So we are not expecting to see pink. If you think you see pink on a spawner survey, you should take a lot of photos because it would be pretty exceptional. These fish are also called humpy salmon. They're the smallest on average because they return after just 2 years. They quickly migrate to the estuary for rearing after hatching from the gravel. And this population, because the fish are small, the reds aren't as big, the reds aren't as deep. So the eggs are more vulnerable to scouring. So if we get a really poorly timed flood in the fall or winter that moves a lot of rocks, then it can really impact the returns exactly 2 years later by killing a lot of pink salmon at the egg stage or alvin stage. Alvin are when the fish are still in the gravel, they've hatched, but they're not yet foraging for their food. They get their nutrients out of a little egg sac that they're born with. Once they finish that egg sac, they're called fry. Pink salmon in the world are the most abundant by biomass, despite being the smallest fish, and by number. And they are super important recreationally and also commercially for fishing globally. And the trend for pink salmon in the Skagit has been very variable since the late 60s, but overall we're seeing a positive trend. And so that is encouraging. We like to see it. So pink are small. They tend to be 20 to 25 inches long. The males will show these features we're going to talk about more, but females can also have them. They get this spinal deformation and it can be super pronounced, so which is why they're also called humpies. And they also get this extension of their kype. They're often a dull gray with a darker back and a cream underside. And then this fish does have spots on the upper and lower lobes of their caudal fin, on their back fin. But these spots are the size of like the end of a pencil eraser. They're big. And this is different than Chinook or sometimes coho, and which their tail spots are going to be a lot smaller. The last Pacific salmon species we're gonna go over is the sockeye salmon. It's also called red salmon. There are river type sockeye in other watersheds, but there's not so many here. So, but in general, sockeye salmon are associated with parts of the watershed that are associated with lakes. They live about 3 years in the ocean when they go to the ocean as adults. In 1992 in the Skagit, they were critical with one return only, including 99 fish, returning in 1986. However, this has been a success story, and humans have figured out how to get these fish around the dams that are on the Baker Lake system. And in 2015, there was the biggest run recorded in recent history. And here's the trend line for that. These fish, 18 to 30 inches on average. So they're the second smallest, only pink, only compared to pink. The males often can have a hunchback, just not as pronounced as pink. They often have a enlarged kype, kind of like a coho. They are often vivid red on their bodies. This is different than a coho, which is more of a dark red or a maroon. And they can have bright green or olive head coloration and with an abrupt change from the head to the body. And then you're not going to see any spots on the dorsal fin or the caudal fin. They tend to run August to November. The only time we're going to expect to see kokanee in this program is on Mud and Finnegan Creeks. And it's going to be a type of sockeye called kokanee. And these fish complete their entire life cycle without going out to the ocean. The fact that they don't get access to marine nutrients is one of the reasons that overall their size is much smaller than the 18 to 25 inches that we talked about on a previous slide. They're going to be more like a maximum of 18 inches. They were stocked in mud and in the lakes associated with Mud and Finnegan Creeks, and they still may be stocked annually. So we do survey those creeks and we do see large numbers of kokanee. So unless you are assigned to Mud and Finnegan, if you think you see a sockeye, take a lot of pictures because they are not going to be common in the other reaches in this program. Okay. Does anybody have any pressing questions about the 5 Pacific salmon before we move on to a brief overview of some of the common trout. Okay, excellent. This section is new from last year. We added it based on your feedback. You'll have another chance to give feedback at the end of this training, and you should know that we read over every single one and try to make all of the changes that you request. So keep that in mind. We did have a team find a cutthroat trout during spawner surveys last year on Swede Creek, and they did an excellent job taking a lot of good photos and to confirm that ID. So first thing we're going to talk about Oncorhynchus mykiss, which is a fish that is closely related to the Pacific salmon. And the common names are steelhead and rainbow trout. It's the same species. And they're called these two different names because steelhead are fish that are anadromous. So they spend some time out in the ocean before returning to spawn. Rainbow trout are the same species, but they complete their life cycle completely in freshwater. And these different life approaches cause them to be a different size, like a kokanee and a sockeye, and they also lead to them being a different color. We don't expect to see a lot of steelhead because they typically run in, they're typically spawning at a different time of year. They have summer and winter runs in the Skagit. This species, like Chinook, is listed under the Endangered Species Act as threatened in the Skagit. They are also identified as a species of greatest conservation need under the State Wildlife Action Plan. They are found all over the watershed in basically every habitat type. If they can get there, they'll be there in low numbers. And unlike the 5 Pacific salmon, it is possible for robust, healthy individuals to spawn multiple times. It's not super common because the process of returning from the ocean to the freshwater to spawn is super hard on them. So it has to be a really healthy individual to do that. Here is the trend line for Skagit winter steelhead escapement. It's just trending down, not what we like to see in a species listed under the Endangered Species Act. So you'll know you're looking at a steelhead. They've got spots all over their body. They've got spots on their adipose fin. They got spots on their dorsal and caudal fins. When you've had the chance to see Pacific salmon versus trout, you'll see that they're, a species like Chinook can have a lot of spots, but trout have a lot of spots, a lot more. Steelhead can have slight rainbow coloring, a pinkish hue on the sides of their body, and a silver belly and a dark back. You'll see that in basically all salmon, and definitely in their ocean form, because from below they want a light belly because predators looking from below at them see daylight coming from the water. So it's a camouflage on a light background. On the back, a lot of them are dark and have spots because when you're looking down into a creek, it's a dark textured color. So it's so they can hide. Steelhead can get up to 40 pounds, but they average 8 to 11 pounds when they're adults. These features highlighted in red are going to be the features that you look at to tell the difference between steelhead or rainbow and cutthroat, because rainbow and cutthroat trout can be really similar looking to each other. So in a steelhead or rainbow, the upper jaw is smaller, and you'll get to see how big the mouth is compared to the fish by looking at where the back of the mouth lines up with the eye. And in this drawing, it's actually not illustrated very well. So we'll look at the next one. If you are looking at a dead individual in their mouth, there's also going to be no teeth on the tongue. So here's a photo of steelhead and spawning colors, very spotted, gray, light pink hue on the side, spots on the adipose fin. So now we're going to talk about rainbow trout, which is the same species as steelhead, but they, as I said, complete their life cycle entirely in fresh water. They have a really varied diet and will eat just about anything. They eat zooplankton when they're young. As they mature, they'll forage on fish eggs, small fish, crustaceans, insects, and on the WDFW info page on rainbow trout, it said they'll eat mice if they can get their mouths around it. So they're very They're very adjustable. They're on what they're willing to eat. They prefer habitats that are really dense with aquatic vegetation, and they'll also eat land insects that fall into the stream. And you don't get land insects in water without that nice, dense riparian stream-side vegetation. Rainbow trout are extremely athletic fish. They can leap up to 3 meters up a waterfall, so you can find them above quite large looking obstacles in the stream, but they're not barriers because these trout are able to get past them, and they live about 4 to 6 years in the wild. You'll see again black spots all over the body, on the adipose fin, on the dorsal fin, on the tail. Rainbow trout average 11 to 18 inches. That's a lot smaller than the 8 to 11 pounds that a steelhead can be. And then this photo illustrates the mouth size feature that we want to remember when we talk about cutthroat in a minute. The mouth is small and typically doesn't extend past the back of the eye, except in large individuals over 20 inches from nose to the end of their tail. They'll have no teeth on their tongue, and there is not a structure back here at the back of the head, like an orange cutthroat slash mark. Cutthroat trout are named for that feature. Common name is based on that feature. So steelhead and rainbow do not have that feature. Rainbow are named for their brilliant colors. They can be blue, green, yellowish, have some silvery shading. They're light on the underside, darker on the back, and then they can have a horizontal pink or red stripe. That's quite colorful. Okay, now we're looking at cutthroat trout. This species spawns in the spring, but they are present all over the place. So it is possible, like our friends on Swede Creek last year, Catherine and Doug found. Cutthroat can be anadromous, that's the coastal cutthroat or sea run cutthroat, or they can be a resident, which they do their whole life cycle in freshwater. These fish are also widely distributed throughout Western Washington and even west of the Cascades. They're extremely athletic, and they can get past all kinds of obstacles, beaver dams, waterfalls, etc. Cutthroat can be found all around a stream, but a lot of what they prefer is small headwater streams near barriers, and they're very territorial with other fish. So you'll see them drive off juvenile coho, for example, for the best habitats. These fish are extremely spotty all over their body, including spots on their adipose fin. Their mouth is large, and the back of their mouth will extend past the back of the eye, even for individuals smaller than 20 inches. And if you open their mouth and look at their tongue, they have teeth on their tongue. And if you look at the back of their head here, you can see the orange slash the cutthroat structure on the underside of the lower jaw. They average 7 to 9 inches, so in general, smaller than the rainbow trout, but obviously juveniles will be similar sizes. This is in adults. The bodies of these fish are, again, quite colorful, blue, green, yellow, silvery. They can have red hues. So color isn't a great way to tell the difference between these two species. And finally, we'll talk about bull trout, Dolly Vartan. These are two different species, but they look so similar that you need more training and potentially DNA testing to tell them apart. They're a salmonid. They are a char species, so they'll still have an adipose fin, but they're not a salmon or a trout. They're the only fish that's going to have a dark body and light spots. They do spawn in the fall. Like some of the other trout, they are able to spawn more than once when they're very healthy, and they're also anadromous. They can be anadromous, or they don't have to be. This is a very rare fish. So if you see this fish, you'll take a lot of pictures for us. We have seen spawning bull trout, a video from a landowner on Swede Creek. So they are around, but if you definitely see one of those, take a lot of pictures. Okay. The next section is going to be on how to collect data for this program. I'm going to pause again for questions. Okay. Don't hear anybody, so we will press on. So what makes good data? You all, everybody who volunteers to survey a stream, are going to be out in your free time in the inclement weather doing hard work. And so we want to collect quality data because it makes it all worthwhile. If we have low quality data that ends up turned into us, or if data aren't turned into us, then it's not, there's no benefit to all the hard work that you're donating to us. So good data is complete, which means both that we're going to survey our streams every 7 to 10 days without gaps. And it also means that on the data sheet, every box is filled out and we don't leave any blanks. And good data is also accurate and legible. And this, it sounds obvious, but it's hard to write in a readable manner when your hands are cold. And it can be hard to collect accurate data when you're counting large numbers of fish. We'll talk about some tips on how to deal with that. So the protocol is that you're going to walk your creek to get familiar with it before, which you can do that before collecting data. Some folks go and check their creek out right away after this training, and they take a machete and they slash their way through and prepare. You can also just collect data on your first creek walk. That's actually what most people do now. You're going to collect data every 7 to 10 days. You're going to walk upstream on most reaches. If you do any downstream, if you do any walking in the other direction, it'll be if we tell you explicitly to do that on that reach. But otherwise, almost everyone in the program walks from downstream to upstream, and you only survey in one direction. So if you're walking up your stream and you don't see any salmon, and then you finish your survey and then you're walking along the stream back to your car and you do see a salmon, you can put that in the notes, but that is not part of your survey. We have to, that's a rule that we have to follow because the data is not comparable year to year. If one year a group surveys up and down, and then another year folks only survey up. So we have to do the same amount of effort each year to compare year to year how many salmon we're seeing. So again, if the only salmon you ever see is on the walk back to your car, and you do find a carcass, you see a salmon, do put that in the notes, but don't count that as regular data. Don't add that to your count. We do not want you to survey if the flow is too high. This can affect human safety, which is not what we want. Or it can also increase turbidity in the creek and make it not possible to see the salmon that you're trying to count, and makes the data not accurate, which is not what we want. If you can't walk your creek due to an illness or another obligation, then please let us know, but do not fill out a survey form with 0 fish, because unknown amount of fish, because nobody counted, is way different than walking your stream, counting and seeing 0 fish. Totally different. Near the end of the season, you're going to keep walking until you haven't seen fish for 2 weeks in a row. That's important. So some folks, if they know they're going to miss, will line up a substitute because they know other people in the program, and that's okay. We do not want you to arrange a substitute person who doesn't have volunteer paperwork in with us. If you get hurt while doing this, you're covered by our LNI insurance, but you have to have your volunteer paperwork. So it is okay if you have a friend or a family member who's interested in doing this and they want to come with you, even if they just want to come once, but you have to let us know, and they have to fill out the volunteer safety forms. Otherwise, it's just not safe. And if you don't check on your creek, even if you know your creek really well, even if you know there's no salmon, if you didn't actually go out and count, please do not write a 0 on the data sheet and turn it in. So here's a copy of the data sheet that we have. We're going to talk about how to collect data on this data sheet because everybody is going to fill in one of these data sheets for every survey. Some folks get this data sheet from us printed on Write in the Rain paper and they carry a clipboard. That's totally fine. We can provide you with a clipboard and with the Write in the Rain paper. A lot of folks don't like to manage a clipboard, and their hands can get cold while holding a clipboard. So what they do instead is use a Write in the Rain notebook to collect this data, and then to submit it, you're going to fill out this data sheet in your house where it's nice and warm. You can do it on paper or digitally and then send it to us. So we're going to talk as if you're going to fill out this data sheet, because everybody will, but some people will fill out this paper, this form in their house, and some people will do it in the field. if you use a Write in the Rain notebook, make sure to do some prep to remember to write down all of these things. So first thing you're going to do is you're going to determine if it's reasonable to survey. You're going to check in with your survey team, the one or more people you're walking with, and you're going to ask if everybody has their personal protective equipment. Do you have enough layers to stay warm? Do you have your waders and boots to stay dry? Do you have, do you have your first aid kit, your EpiPen that you might need? Everybody's got to be safe. And then you're going to check in and make sure that nobody's ill. Nobody has any COVID symptoms. We don't want to be volunteering while sick. So, and then you're also going to assess the safety of the situation. It's a guarantee. Most people, if not everyone in this program, is going to have to delay a survey or skip a survey due to unsafe conditions. This can include high water flow or flooding. It can include flooding over the road that prevents you from driving and parking to the site. It can include high winds, which can break off branches in the treetops and put you at risk for those branches falling and hitting you. Those are called widowmakers in the logging community, because if you're unfortunate enough to have one fall on you, it can be really, really dangerous or even fatal. So if you've decided that it is safe to survey, you'll fill out the stream name, super important, crew members, the name of the crew lead that day. That's usually the person that writes down the data that we're going to be getting the data from, and it can change between surveys or not. It depends on your team. And then this is an old form. You'll also write the date, and there'll be a space for that. So fill out the header, because if we don't know who's there and what stream you're on and what day it is, then we can't use the rest of the data you collect. At some point during the survey, either sometime between the beginning or the end, you're going to write down the flow type. This is going to be stream dependent, so it'll get easier as you get familiar with your stream. But for that stream, is it low, medium, or flooding? If it's flooding, don't walk, but you could perhaps drive out to the site, see that it's flooding, not surveyable, the water is turbid, and you could fill out that section and then send it to us. That is data that we do want. But if you look outside and you can see that it's flooded, then go ahead and don't fill out a survey form. Just let us know that you didn't, it was not safe to go. The visibility is going to be how well you think you can see the salmon that are there. The water conditions are going to be, it's related to visibility, but it also has to do with the water conditions are water specific, and visibility can also factor in things like really high glare. So if you think you might have not been able to see some of the salmon there because of the light conditions, then that can go into visibility, but it wouldn't go into water conditions. Just do your best and let us know if you have questions. And then the note section at the bottom can include anything. It can include salmon that you observed outside of your reach area or reach time. It can include a cool wildlife sighting, like if you saw eagles feasting on carcasses there. It just, you can, whatever you think we might want to know, you can put it in the notes. As you walk upstream, you're going to record all of the live fish that you see by species. This can be difficult when there is a really good return, which this year is forecasted by WDFW to be a really good return. In this case, if you see dozens and dozens of fish all at once, it can be really daunting to do an accurate count. So the best way to do this is not 1, 2, 3, 4, 5, 6, because fish are moving around as you're counting. It's going to be to do batches. So you'll say that's 10 fish plus another 10 plus another 20. Okay, so 40 fish in this pool. And if there's many fish, there's also a benefit to having everyone in your group do their own count, and then for a section, and then get together and report your numbers, average them, and write that average down. That has been scientifically proven to be more accurate than one count. You know, those games where people guess how many gumballs are in a vase? When you average those hundreds of guesses, even though each individual guess can be really wrong, the average of guesses tend to be pretty close to the truth. So it's a good strategy to get the live count. Obviously, if you're able to count every individual salmon with high confidence, do that. But if you're just overwhelmed by the number of fish present, count them in batches, 10, 20, 30, 40, etc. Do your best to identify them to species. If you've only ever seen coho, ever, and it's November, you can be pretty confident, even if you don't get a good look at a live fish, that it's a coho. If it's early in the season, you know there's coho and Chinook present, you can write unknown, but we want you to do your best, most educated guess in the field and minimize the number of other or unknown. If you write any other or unknown live carcass or red, then please write in the notes why you did that. When it comes to carcasses, you're going to count every single one and identify them to species. You're also going to check if they have an adipose fin. I've got a slide about that in just a second. The reason we do this is because wild fish have adipose fins and hatchery fish often have clipped adipose fins to indicate that they're a hatchery fish. And we're not going to see a lot of hatchery fish in this program, but if we do see one, we do want to record that we did. If the fish is decomposing, it's kind of a smelly carcass that's been out there for a while, the adipose fin can be kind of degraded and stringy. So a true fin clip nursery fish, hatchery fish, is going to have a nice flat, long healed wound where the adipose fin was clipped when they were just a few inches long. This will be years later. And a recently decomposed adipose fin will be tissuey and stringy. So that would be a wild fish that's just decomposing. You're going to take length on the first 20 carcasses that you see and also determine sex. That's on the next page. And then after that, you can just identify them to species. You don't have to determine sex and length. The length of a fish, and we'll demonstrate this when we do the dissection, is from the end of the kype, the nose, to the fork length of the tail. And I'll point that out on this slide. So all of these fish don't have, they typically don't have a totally flat tail. Their tips of their tail are longer. The rays are longer than in the center. So if you decompress the tail, the length of the fish could change if you're measuring to the longest point. So to avoid that, to take better, more accurate scientific data, we're going to measure length from the kype to the fork of the tail, and that's called the fork length. And we're going to do this accurate to the nearest centimeter. Don't have to get into millimeters, especially since these fish often have really damaged tails, which can shave off a few millimeters off of the natural length of the fish anyway. So to the nearest centimeter is fine. We do metric in this program because it is science, and we are part of an international community of salmon appreciators and restoration folks. So we do it in metric. This photo of a scientist holding a salmon fry shows the size that the fish are typically when the adipose fin is clipped. So it's a long time to heal between that size and then the size that you see in adult. After you've collected your carcass data, which can be pretty gnarly and might make you make a face like this volunteer, we're going to cut off the tails. And that's because we want to leave the carcass where we found it, let the nutrients go into the environment, let the scavengers get their meal. But we don't want to count this carcass again on another week. And it does take more than a week for carcasses to decompose. So you're going to, after determining the sex, after opening the fish up and seeing if it's male or female, you're going to cut off the tail. And then on future surveys, any fish missing a tail, you're not going to count it. If you find just parts of a fish, you can note it, but please don't count it. We're only going to count bodies of fish that have their tails on. So if you find a little piece of the head scavenged, put that in the notes, but don't write it in the total. And finally, we're going to count reds. We'll have a part of the outdoor portion where we look at how to identify a red. And then we've got some photos in this section too. And again, reds are the nests that salmon put their eggs in rock and gravel and bury them to protect them from the conditions in the stream and predators, and from the fall when they get deposited there to the spring when they hatch. When you identify a red, you're going to mark it with green flagging, and everybody is going to get green flagging in the kits this afternoon. We do this so that we can keep track of where they are and so we don't step on them. And so the flagging is going to have the date, the organization you're working with, so SFEG, and the code if you know the species. coho, chinook, chum, sockeye, pink. And you're going to use those biology methods we talked about above to determine what species are present. If you've only seen coho and then you find a red, you can call that a coho red. If if you're getting a mixture of coho and chinook, for example, and you see reds of super different sizes, you can say unknown. Chinook reds are going to typically be really big, but multiple coho reds near each other can look big. If you have questions about this, then if you're having so much spotting and so many reds that you have questions, then touch base with us and we'll walk with you or we'll help you. So, but flag the reds and then don't walk near those flaggings in the stream. In fact, most of the stream surveys that you all do, we want you to walk next to the stream, not in the stream, because we don't want to accidentally trample on reds. If you have to walk in the stream, we encourage you to crisscross and spend as much time as possible on the bank and out of the water. This is also safer, more likely to stay dry. And when you cross, we want you to look for boulders that you can step on or sand and mud that you can step on, and you're going to avoid the ideal gravel in a riffle habitat that might be great for reds. We're going to avoid that. This is a happy volunteer wearing her protective equipment, including a vest and waders. And she's tying a piece of green flagging on a branch nearby, but not on the red. And I'm sure she carefully walked out there and made sure she wasn't stepping on a red to put that flagging out. So reds are going to be located in gravel, and bigger fish tend to prefer bigger gravel. This gravel substrate can vary from 1.3 centimeters, which is less than an inch, about a half inch, to 10 centimeters. That's more like a grapefruit. And it's going to depend on the fish size. They want to dig the biggest, most protective nest that they can for their eggs. And you're not going to find these in spots where there's high or 100% sand and mud, because the eggs need access to oxygenated stream water flowing over them at all times, or they can suffocate. If a flood or other disturbance causes sand or mud to cover a red, then it suffocates the reds. So we're also going to be careful to not stir up a bunch of sand upstream of reds, to not let that happen because of us. You can also look for spawning behavior. Sometimes after spawning, females will guard their red, and until the end of their life, they'll prevent other females from digging it up. If you see the beginning of spawning of red behavior, if a female is digging a red actively, you don't count it as a red until you actually see successful spawning, because sometimes they get abandoned or perhaps eaten before they're done with building their red. You can note it for the next survey a few days later and count it the next time if it looks like it was completed. We're going to look at this in other slides, but in this photo, you can kind of see there's a color difference between the rocks underneath these salmon and the rocks that are not underneath the salmon. You can also see a difference in substrate size. So notice under the salmon how there are bigger rocks and there's more small rocks and some sand around it. So when fish dig, it's by turning sideways and using their tail. And that method moves the small substrate before the big substrate. And what's left over at the bottom of their red is rocks that are too big for them to move. And even when they cover them back up, what's left over is going to often, the red, since they just flipped rocks over, is going to have less of the benthic algae showing on the new upright side of the rocks, because the fish digging scraped it off. So it can be a different color temporarily for the first few days. And then there's going to be a circle of different size rocks that you can't explain by just stream activity alone. Here's a picture of a female chum digging a red. You can see her calico stripes on the side, and you can see those on the males behind her as well. So she's turning on her side, digging. A lot of the reason that tails are often really ripped apart and can't be used as part of identification is females will dig even as it's ripping their skin and scales off and shredding their tail. They're determined, and they die anyway from spawning. So they give this all they got. The males are behind her. eyeballing each other, probably beating each other up, trying to be right at the back of her right when she's done, so they can fertilize her eggs. So you will likely see this, see females digging and see males competing and fighting each other. There also can be sneaky males where during spawning of the dominant male who won and the female that dug the red, you can sometimes see sneaky males doing like a swim by fertilization, just trying to get a few eggs to be his instead of the dominant males. And smaller fish, it's some species of salmon mature, a small subset of individuals will mature early. They're called jacks. So in a coho run, you might have all these normal adult, regular size coho, and then you might see one typically male fish that's much smaller than all the others, but has all the same features regardless, other than being small, all the same coloration and physical features as the other fish. And these are sexually mature fish and can reproduce, but they typically use the sneaky method because they're not big and strong enough to dominate the space and to compete with the other big males. Here is a cross section. I'm gonna move this. Here's a cross section of a red. So before the material is disturbed, a lot of fish tend to like this transition area between a pool and a riffle, and that's because the water moving through the pool hits this material, and some of it will get forced down into the groundwater, and this is called downwelling. This is the opposite of upwelling, which is where water comes out of the ground into the water column. And downstream of this is a more shallow riffle habitat, and you'll see riffles. Pools will typically have flat water on the surface, and riffles will have uneven water on the surface. So once a salmon identifies this as a good spot, she will she'll turn on her side and start digging, and she'll make this pit. And this pit encourages even more downwelling. And this forms a tail spall area, and eggs will be deposited in this pit right on the side where you see all this downwelling. And then finally, when the female is done, she will cover up her eggs, and she will make, this will be the end result. You've got the pit. This is where you'll see a lot of the big rocks that are left behind that she wasn't able to move, and these will all be all this disturbed material will likely be a different color than the regular stream bed at the beginning, and then you get the algae growing on these, and it blends in again before too long. And then you've got this tail spall that the female makes that is all buried. It's the material she buried her eggs with. So contrary to popular belief, it's not like a bird's nest where the eggs are in the bottom of the pit. The eggs are actually in the tail spall, here where the downwelling is. So if you identify a red and you're trying to stand away from it, you're not going to want to avoid the pit and stand on this tail spall. You'll be standing on red. So you're going to want to stay out of this whole area and be really careful about walking up river upstream of the pit and the red, and just stand next to it, or even better, stand out of the stream next to it when you're labeling this with a flag. Excuse me. Talking too long. Here's another cartoon of it. You've got the water surface, you've got the pool here dug by the fish where she removes material here and uses it to bury the eggs. The eggs will be here in the tail. So this entire thing is a red, but the place where the eggs are is going to be over in this tail spall. Reds, as I said, can be quite large and a different color than the substrate. So these are Chinook reds. Chinook are really big fish, again, that prefer spawning in the main stem. I don't know what river this is. It's not this, I don't think it's the Skagit, but Chinook reds can be so big that in some rivers that are especially clear, you can do red surveys with a helicopter. And so these are multiple feet across and multiple feet wide. Smaller fish will have smaller reds. And this color differentiation goes away. It really depends on the stream, but in about a week. So every time you see a fresh one, every time you survey every 7 days, you'll see any fresh that you see you can be confident that it's a fresh red. So here's another photo of red. Here in the middle, you've got the big rocks in the pit. And then the water is going from the left down to, let's see, which way is the water going? So this is going to be the riffle. So this will be where the eggs are. And this stream is not a great example of, in this stream, you don't have a lot of algae growing on the rocks. So there's not a big color difference. And that makes it a little bit harder. So then you got to look for this texture indication. Here is an example of a stream where there is a lot of algae, and there's the benthic environment growing on the rocks gives the rocks a different color. So you can see that and you have to look closer at the substrate to see if this is multiple reds near each other or just one super red. You can see the color differentiation from the rocks being flipped over and scraped off by the digging. And this is a picture of spawning behavior. So you can watch for a few minutes. If you see spawning, you can count it. But if you just see females just starting to dig, then you won't count it as a red. Finally, after you're counting your live, your carcasses and your reds, you're going to be recording pre-spawn mortality on the back page of your form from your 20 carcasses that you dissect. Pre-spawn mortality is when a fish makes it to the spawning grounds or near the spawning grounds, but it perishes before it's able to successfully complete reproduction. And we know that we're looking at a pre-spawn mortality when we open the fish and we find that their reproductive structures are full of milt, which is what you call sperm in a fish, or eggs. So a few eggs or like a little bit of milt left over is not going to be a pre-spawn mortality. The fish has to be, before they've spawned, they're full of reproductive material. So when you open it up, it'll be pretty obvious. Some people, before they dissect the fish, will do something called the boot test. So especially if a fish looks freshly dead and has a big swollen belly, you can take your boot and poke it. And if milt or eggs squirt out the vent, which is the one hole that they both, they eliminate waste, digestive waste out of, and also reproduce out of. If you poke a salmon and eggs squirt out all over it, then you can determine that it's female and that it also may be a pre-spawn mortality. You might want to open it up and look at the number of eggs to see, but if it's hundreds of eggs still left, pre-spawn mortality. Coho are very prone to pre-spawn mortality, especially in other watersheds. So we collect this data because we're an index watershed, because we tend to have healthier streams compared to the rest of the state. So places like Seattle will take their pre-spawn mortality data and compare it to ours. But coho are very sensitive to pollution, especially road runoff. And so especially early in the season when we get big rains, the runoff from the road can enter the stream and it can kill the early part of the coho run. So we might see it. If we do have it, we want to document it. So you're going to be marking if something is a pre-spawn mortality, yes. And then in the notes, you're going to write the species if you can determine it, and other notes about the fish, maybe where it is in the stream. If your boot check isn't completely obvious and there's just reproductive material spraying everywhere, then you are going to have to use perimeters or a knife to open the fish up to determine the sex and if it's a pre-spawn mortality. This is an example of a pre-spawn mortality. So a few eggs, 5, a dozen, that's not enough. The females that have not reproduced yet are just full of eggs like this. So it's more obvious in females even than males. And we'll talk about this more when we're doing a field dissection in the afternoon portion. So some volunteers in some years may not spot salmon. Hopefully that won't happen much this year because the forecasts are really good. But it's still really important data, especially if you're assigned to a stream it's surveys before a project. We use that directly to compare with data we collect after a project, And also if you do see salmon that are held up by something like a culvert, then feel free to take pictures and document that. If you are missing salmon or you just can't get enough from your stream, then we are going to have salmon sightings. The information about this is on the website and you can ask any of us later, but these are events that we host in places where there's a good chance there will be adult salmon, and you can join us and see some of them. We're expecting Chinook at the Pomona Grange Park salmon sightings in October. We're expecting chum in November at Oyster Creek. That's near Bellingham. And then in December, there's several species that use the Presentine Park channel. And one of them is a channel that's been there for decades. And one of them was just constructed as a restoration project. And so we're still finding out what species that we can see what time of year, but that's all the way up in Marble Mount, but it's definitely worth a visit. Okay. So thanks for hanging in there. There's a fun quiz for anybody who's still awake to check what you've learned. So do we want to unmute and give it a go? This quiz is it's going to be just shout out format. So Mariah and Kenzie are down. Woo, they're AmeriCorps, so AmeriCorps folks are always down for the hard work. Love that about them. What salmon are going to be spawning in December? Oh, you saw the answer. It's coho and chum. I'll do better, I promise.
I was going to say that anyways.
Yeah, you were. Okay, so here we've got some gnarly salmon carcasses. These photos were taken by previous volunteers who were brave enough to collect data from them. And so we're gonna look at what these are. So top left, what is it? And you can ask questions that you could determine in the field.
Looks like chum to me.
Chum. So this one is really hard to tell, but it was a coho. It's decomposed, and that's so the spots on it aren't calico. It has a red body, and it was found in a stream where only other coho are found. So you can use that as a sign. But it's really, these are hard. Okay, let's do top right. It's a large fish.
That one is a chum.
That one is a chum. Yeah, it's got a small caudal peduncle. You can see some tissue left on the tail where you wouldn't see any spots. That one's a chum. That one's a coho. It's not in the order I thought, guys. This is a struggle. This one down here revealed itself as a coho. It's got a red body and a green back. It's got spots on its tail and dorsal fin, and it's got that white nostril structure and a large kype. It's a chum, as we said, and then this is the last one.
Chum?
It's a chum. It's got big teeth. It's got a dainty caudal peduncle. If you were seeing this fish in better light, you might notice that some of this modeling is truly calico stripes and not just decomposition. So these are the kinds of not textbook, not perfect carcasses you'll see in the field. Okay, this one's a hard one. This is a large fish with a damaged tail that you found in a large stream in October. So what feature do you look at next to confirm the ID?
The mouth?
Yeah, that's right. You're going to check the mouth, because this is olive. It has spots on its back and its dorsal fin. It's a big fish in the right time of year and the right habitat to be a Chinook. This tail is damaged. This is likely a female who's been digging reds, although you'd want to cut it open to find out. So you'd want to see if you can check the mouth and see if it's got black on the bottom jaw next to the teeth. What is this? Found in a stream associated with a lake.
Kokanee?
Yeah, it's a kokanee. It's dead, so the colors have faded, but red body when it's alive and green head. So kokanee, which is a type of sockeye, and it's really little. This is a pretty typical size. What is this? And you can also say how you know if you want some bonus points.
Okay, if nobody's gonna go, I'm gonna say coho.
Yeah, it's a coho. This one's a little bit hard. It does have a very red body and a green head. So this is an especially red coho, but it's got a really big kype. It's got this white structure where the nostril is. You're going to check the gums and see that it'll have white gums. And then it doesn't have spots on its tail. Okay. Which is the correct protocol if you can't survey your creek? Do you write a 0 on your data sheet and promptly submit it to our AmeriCorps member, Mariah Crowley at skagitfisheries.org? Do you report that you won't be able to make it to SFEG so they can send a substitute team? Or do you skip surveying that week and just make sure you return to survey the next week?
I think it's B.
It is B, exactly. Yeah, and we've mentioned this multiple times, but it's one of our most common data mistakes with new surveyors. So we want to make sure that we know what to do. So when would you put it 0 on your data sheet for any of the things that we're looking for?
If we didn't see any fish.
Yeah, when you walk your stream and you don't see any fish, because 0 is a number. Exactly. And we're hoping to start early enough on surveys that you will get 2 surveys with 0 fish before you see your first fish. That way we're sure that we got the beginning. But we'll start surveying within the 2 weeks of this training, and that will likely get us a few walks with no fish. And that's the end. Thank you for watching and being here. Does anybody have any questions?
Thank you, Erin. That was great.
Thank you.